Here's the same quadratic function as we had in the last part. We're going to answer 3 more questions about it. The first of those questions is to locate its zeros. The zeros of a quadratic function are where on the x-axis this parabola crosses. It could be in 1 point at its vertex, could be in 2 points, or maybe it doesn't even cross at all, and then the zeros would be imaginary. Either way, we would find them in the same way as we're about to do this. The whole idea is that on the x-axis, the y values are 0. And since f of x equals y, what we're going to write is when y is 0, that's what we're saying, what is x? And that means we're going to have to solve this quadratic equation for x. And we're going to do that by factoring or completing the square or the quadratic formula. This one doesn't factor. I'm just going to use the quadratic formula here. So the quadratic formula is negative b, so 6, plus or minus the square root of b squared, 36, minus 4 times a times c, which is 24. And that's all over 2a, so 6. I'm going to simplify this down as far as possible. 6 plus or minus the square root of 12, all over 6. So x equals 6 plus or minus 2 radical 3 over 6. 2 radical 3 is what radical 12 reduces to, because radical 12 is just radical 4 times radical 3, and the square root of 4 is 2. We're going to divide all 3 of these by 2 and get 3 plus or minus radical 3 over 3. Now I'm going to write these as coordinates, and so that's going to look like this: 3 plus radical 3 over 3, comma 0, and the other one is going to be 3 minus radical 3 over 3, comma 0. The next point that we're going to find is the y-intercept, and it's kind of the same type of thought process. The y-intercept would mean that the x value is 0, and that means we're just going to evaluate this quadratic function at 0. Now, if this point is what you're looking for, you're not really going to do this too often, because what's going to end up happening, and what I mean too often is you're not going to evaluate this function for 0, because what you're going to notice here is that the y-intercept is always going to be your c value. So that means when x is 0, y is 2. Now, a parabola looks like this, and so what you should see is these are the same y values, or these are the same y values, right? They're the same height. Okay, so what that means is there's going to be another point, and it's going to be the reflection of the y-intercept, another point where y is 2. So we want to find that also. So same kind of idea here. If y is 2, then we're going to substitute that in for f of x, and so you're asking yourself the same kind of question. When y is 2, what are the x values? Now you got to get this set equal to 0, and when you subtract 2 from both sides, you're going to get, those are going to disappear, and so what you're going to have is 0 equals 3x squared minus 6x. This is always going to be something nice and easy to factor, so I'm going to take an x out of, factor an x out, and you're left with 3x minus 6. I'm going to set both of those equal to 0. X equals 0. Now we already knew that one, right? That's what we started with, and again we're looking for both of them. So we are going to set 3x minus 6 equal to 0 also. Solve this. 3x equals 6. Divide through by 3. X equals 2. So the reflection point of the y-intercept is 2,